Hello everyone, welcome back to Code Studio, and in this video we'll be discussing the basics of process scheduling by operating systems. This will be a series of videos which will give you all the information you require for your college exams as well as your technical interviews. So without any waste of time, let's get started with this no BS easy course on process scheduling. We all know that there are processes that are run by operating system, and different processes have different times of completion. Like one process might take 2 seconds to finish, other process might take 40 seconds to finish. One process might start at 10 a.m. and other process might start at 10:02 a.m. And there are different processes that get bombarded to the operating system, and there are different times of completion, right? So it is a task and responsibility of operating system to efficiently handle and manage all these processes, and we'll basically discuss different strategies used by operating system, some standard strategies that we know. There might be some different strategies or a mixture of couple of strategies that are used in the real-time operating systems, but we will be primarily discussing 4 different standard strategies in this course. Coming to how processes arrive, I will give you a small example and I'll make you understand like how processes arrive and how OS basically manages it. With the same flow, I'll explain you some terminologies which are very important in analyzing different strategies used by operating system. So here is a table that I'm presenting to you, which basically gives you an idea of what different processes are present in the operating system, what is the arrival time and what is the burst time. So arrival time is basically the time at which the process arrives to the operating system and tells I'm ready and I'm ready to get executed. Burst time is basically the time taken by a process to complete. So with this given example, we can see that P3 enters first into the operating system and it takes 3 seconds to finish. Second comes P1, which takes 5 seconds to finish. Third comes P5, which takes 4 seconds to finish. And there are 2 processes that come at same time t equal to 6, which takes 4 seconds and 2 seconds subsequently. So this comes at position number 4 and this comes at position number 4. So this is the table that you generally see in your college exams or elsewhere to solve different strategies or problems of process scheduling. I'll basically use this type of tables in the subsequent videos too. Now let us take a timeline to understand when the process arrives into the operating system, right? So let us draw a small timeline which is basically denoted here, and let us denote when the process arrives to the operating system. So we know that P3 arrives at time t equal to 0. So let us write P3 arrives here. P1 arrives at time t equal to 4. So P1 arrives here. Next P5 arrives at time t equal to 5. Then at time t equal to 6, P2 and P4 arrive. So here P2 and P4 both arrive at this time, right? So as you can see, this is the positions when the process enter into the operating system. Now let us draw how much time each process takes. P3 takes 3 seconds to finish. So from time t equal to 3 tak, the operating system is blocked on P3. The operating system is solely doing the task of P3. Now from time 3 equal to 4, operating system is free because there are no pending processes that it need to finish. Now at time t equal to 4, P1 is there. So it takes 5 seconds to finish. So from 4 to 9, it is basically blocked on P1. Meanwhile, all the other 3 processes came, P5, P2, P4. They all came in between when the operating system is blocked on P1. Now, it is the task of operating system to choose either P5, P2 or P4. It might be the case that P2 is very important and I need to pick up P2, and the operating system might stop at time t equal to 6, stop P1 for some time, pick up P2 and finish P2, then come back again on P1. So these are the different strategies, right? We can assign priorities to processes, and based on the priority, the operating system thinks and efficiently stops other processes and starts another process. Or we can just say P5 came in first, I'll pick up P5. So let's just consider that case, and P5 takes 4 seconds and it takes until time t equal to 13, the operating system is blocked on P5, then P2 or P4, OS can choose any one of them because both arrived at the same time. Now maybe I'll choose P4 because it takes only 2 seconds. So it takes only 2 seconds. I am blocked on P4. Then on I am blocked on P2 for 4 seconds. So it is until time t equal to 19, I am blocked on P2. So this is how the operating system basically handles different processes. And with this given example, I have initially discussed about arrival time and burst time. Now there are other concepts that I need to introduce to you before getting further. So one such important term is completion time. Completion time, as the name suggests, is just the time at which the process is completed. So here P3 completes at time t equal to 3, P1 completes at time t equal to 9, P5 completes at time t equal to 13, P4 completes at time t equal to 15, and P2 completes at time t equal to 19. So this is the completion time that we are discussing. Now another term that we need to discuss is called turnaround time. Turnaround time is nothing but the time taken by a process between its completion and its arrival, and because it is very simple, we can just write down as time of completion minus time of arrival, right? It is basically how much time the process is present in the system, which is from arrival to completion. Now another term that we need to discuss is called waiting time. Waiting time, again, as the time suggests, is how much time the process has waited, right? So consider this case when P5 is waiting from time t equal to 5 to time t equal to 9. It is in idle state. It is ready. It said I am ready, but it is still waiting because operating system is blocked on some other process. So P5 is waiting for 9 minus 5, which is 4 seconds here. So waiting time is calculated as the difference between turnaround time, so TTAT, minus the burst time. So turnaround time is basically the total time the process resides in an operating system queue, and burst time is the time how much the process takes to finish, and the difference between those both gives you the waiting time. And these are some important parameters that we need to look into the problems, and we need to find out the average turnaround time and average waiting time of all the processes in a given process scheduling algorithm to decide which is the more efficient one. So there are two other concepts which we need to know before moving further, which is called preemptive and non-preemptive scheduling. Just before, we were discussing in the example that an operating system might start with one process, and in between it can stop, put the process aside for some time, pick up another process and run it, and later pick up that finished process and again start its execution, right? So this is called preemptive scheduling, wherein the operating system can stop one process in between, put it aside, start another process, and maybe put that also aside when another higher priority process comes, or based on some algorithm it can stop one process in between and start another process. This is called preemptive scheduling. So what happens in this preemptive scheduling is the context of an operating system switches from one process to another process. So the context switching time, which is evidently the time the operating system takes to switch from one process to another process, is generally very minute, but if this happens very regularly in the operating system, then that is something that we have to look after. Non-preemptive is just the opposite. Once the process has started, we should not stop in between. I hope you understood how processes arrive, how OS manages them, and different terminologies used for analyzing these different algorithms. In the coming videos, we will be discussing different strategies with some examples just like how I have given you in this video. Please do like, share and subscribe to this video. Thanks.